every single one of these math problems that we've talked about the fact that in this course, really we're going to spend all our time learning about how to solve math problems um, analytically, or excuse me, numerically, as opposed to analytically, which is much of what you've studied to this point. But really, before we get there, we really need to talk about where these math problems come from in the first place. And that's what mathematical modeling is all about. Every one of these problems that comes up starts with a real world problem. Okay, so there's a real world problem behind any any mathematical problem that you might encounter. There's a real world problem. Now, that real world problem could be uh, any problem. It could be okay. Let's give some examples. It could be a problem from the financial industry. It could be um, a problem in transportation. Uh, it could be a problem energy. It could be an environmental problem. It could be anything. To give you a concrete example, last Christmas break, I worked on this problem of it's an agricultural problem of how to do uh, how to how to cut seed potatoes efficiently. Okay, because you have this problem where seed potatoes have to be, if you cut them too small, then you get a seed that's not viable. It won't grow into a potato plant. If you cut them too large, then you're wasting potentially good seed. And so you have to optimize the way that you're going to cut these seed potatoes. In addition to the fact that you're not going to do it manually and take out a knife and cut them all up. Although that's certainly possible, it's not very efficient. And so there's this complex problem with seed potatoes. That's just one concrete example where you might need to come up with a mathematical model, which I actually did in this case, to address this real world problem, and then you actually solve your mathematical uh, you solve the problem that you come up with. So we start with a real world problem, and then we go through this exercise of mathematical modeling, and then we come up with this mathematical model. Okay, and this whole arrow of going from a real world problem to a mathematical model, that is mathematical modeling. And when we do mathematical modeling, we have to make certain assumptions, and we have to make approximations. Approximations, we can just write right over the top of that. Okay, so mathematical modeling is just moving from the real world problem to a mathematical model by making certain assumptions and approximations, but still grasping the essence of the real world problem. For example, we can compare that to the definition in the textbook, which says a mathematical model can broadly be defined as a formulation or equation that expresses the essential features of a physical system or process in mathematical terms. I just have to point out it doesn't necessarily have to be a physical system. Um, okay, so this is really what mathematical modeling is, and it's important because mathematical models help us solve real world problems. We solve this mathematical model, we come up with that solution, and then we apply that back to the real world situation. And I would also point out that in this mathematical modeling step, we will talk about error more in the following sections, but there is already assumptions and approximations that we make when we come up with the mathematical model. In addition, when we solve the mathematical model, we'll have to make additional approximations, but as long as those approximations are close enough, then we can come up with a useful solution to the real world problem, so that when we apply it, we can do some good in the world, whether it be to increase agricultural production and efficiency, or solve environmental problems, increase efficiency of transportation, whatever the problem may be, depending on your application. These can all be helped through the use of mathematical modeling.